You'll notice on the first 3 questions, it's called the angle of elevation. And if you think about the activity we did outside when we were looking up at the tree or up at the flagpole or up at the stadium or whatever, the angle that you look up with it, as far as the angle that's made with the ground. So that part of it, that part is the angle that it's talking about when it talks about the angle of elevation. Okay, all these triangles, or all of these pictures will be triangles. You just have to figure out where to put the things. But when we talk about angle of elevation, like if you're looking up at something, this angle right here is the angle of elevation because you're looking up at it. Okay? All right, so on the first question it says, at a certain time of day, the angle of elevation of the sun is 35. To the nearest foot, find the height of a tree whose shadow is 35 feet long. This is different than the similarity questions because I only know something about the shadow of a tree. I don't know something about the shadow of somebody else or the shadow of a light pole. It's just of the tree, and we have an angle there, so that's why it's not a similarity question like on some of the warm-ups we can do. All right, so here we go. So we're looking up at the sun, and here's our tree. So where's the 35 degrees? The angle down here at the bottom. And then it says the shadow is 35 feet long. When you talk about the shadow, shadows are always on the ground. If you go outside and you look at your shadow, it's always on the ground, right? Okay, so your 35 for the shadow is down here. And what is it asking you to find? The height of the tree. So it's asking you for the up and down part, so it's asking you for this. Alright, and so this is where we label the triangle, we try to figure out, okay, is this sine, cosine, or tangent, and then we solve it. So x, what's x? Opposite. What's the 35 that's on the bottom, the green 35? Adjacent, so we have tangent here. So tangent of 35 equals opposite, which is x, over 35. Let's put it over 1 and let's solve. So when we cross multiply, the numbers are all together, so we put 35, tangent 35, and you get 24.5. So number 2, we're talking about a wheelchair ramp. You guys told me the other day a wheelchair ramp is kind of like over there near Miss Harmon's room where it goes up. That's a wheelchair ramp. Okay. And it says, okay, here's the wheelchair ramp. It says it touches the doorway 1.5 feet above the ground. Okay, so here's the triangle. And this over here is the ramp, so that's the 12 feet long. Where's the 1.5 feet above the ground? It's the height. It's the up and down part. Okay, and it says find the angle of elevation. So that means that it wants you to find this right here, which I'm going to call x. You have to use the second button on this one because you're looking for an angle. So, Caleb, what's the, if you label it, what's the 1.5? A, O, or H? Okay, start with your X, because X is what you're looking for. So it's the O, right?
Yeah.
Okay. And then, Logan, what's the 12? Yes. Because even though I didn't draw that 90, that is across from the 90. And Ray, so we have O and H, so which one are we going to use? Sine, good. So we're going to have sine of X equals O and then H, so 1.5 over 12. And we've already talked about on this one we have to do the second sine button since we're looking for an angle. Ben, what do you get for your answer? Have you put in the calculator yet? 7.2. Let's think about that a second. 7.2 is in degrees. Talking about a wheelchair ramp. Should a wheelchair ramp have 7.2 as the degrees that it's going up? So yeah, think about it. Think about a wheelchair ramp. And 7.2 is not very steep. If it was like 45, would that be good? Wheelchair ramp, that wouldn't be very good. If it was even 80, that wouldn't be good. So it needs to be smaller because you don't want it to be so high that the wheelchair can't even get up it. Or that it's like an amusement park or anything. All right, number 3. The top of a building is seen from the ground at an angle of elevation of 68. So the building is like right here. And we'll draw little windows. The observer is 40 meters from the bottom of the building. How tall is the building? Garrett, where do you think the 40 is? At the bottom, good. Because that's how far we are from the bottom. Raven, where do you think the 68 is, the angle of elevation? It's always that angle at the bottom that's making you look up. So it's down here. There's the 68. It asked me for the height. So it's asking you for this right here. I put an H there. If you want to put an X there, that's okay. I'll change it to X so that way you don't get confused about hypotenuse or something like that. So if I start labeling the triangle, what would the X be? A, O, or H? Yes. And what would the 40 be? Good. So we have O and A. So Nevada, which one are we going to do? We have O and A. So which one are we going to do?
Tangent.
So we're going to have tangent, write down our angle, then O, and then A. Cross multiply, and let's solve. Jennifer, what did you get for the answer?
95.
Good job. Any questions about 1, 2, or 3? All right. When I talk about angle of depression, it seems like, oh, it must be that angle up at the top. If this angle down here is angle of elevation, the angle of depression must be the top angle. Well, actually it's not. Okay? So here's what happens. The angle of depression, it's like you make this line right here, and the angle of depression is this angle up there that you make with that extra little line. It's that blue little angle. That's an angle of depression. Okay? It's not an angle inside the triangle. Now, that yellow line and the red line at the bottom, they're parallel. So that means that this angle, which is the angle of elevation, is equal to the angle that we're looking for, which is the angle of depression. Okay? When we say angle of depression, we're really talking about that angle outside the triangle that's way up there. But it's the same as the angle of elevation, so we're going to draw the picture exactly the same way that we've been drawing it. Okay? And I know that's confusing because it seems like it should be different. But we're going to use the same information and just draw it the same way. And in these two questions, we're going to look at it in the same way. Okay? So number 4, we have this bird sitting in a tree. And it's 32 meters above the ground. And it sees this little mouse. So there's the 32 because that's how far the bird is in the tree. The little mouse is down here. And it sees the mouse at an angle of depression of 72. So where do you think the 72 is going to go? At the bottom. See, it's really up there at the top outside the triangle, but we know it's equal to the elevation angle, so we're going to put our 72 right there. It says how far is the mouse from the bottom of the tree? So what do you think we're looking for? That down there. We're looking for how far the mouse is from the bottom. Okay. Let's label our triangle. Luke, where's the 32? What's it going to be?
O.
Okay. And what's the x going to be?
A.
So if it's O and A, which one are we going to use?
10.
Good. So we have tangent of 72 equals O over A. Put it over 1. Let's cross multiply. I'll give you a second, see if you can solve for it. Okay, so on this one, when we cross multiply, we get x tan 72 equals 32. So it's a dividing question because the x is with the tan. And so once we do that, you divide by the tangent of 72 and you get 10.4. Okay? All right, I'm going to give you a second. I want to see if you can draw the next one. Don't solve it yet. Just see if you can draw it and figure out whether you should use sine, cosine, or tangent. So 1200 is at the bottom, 23 is the angle, and we're looking for that height x. Okay, so what do you think you're going to use, sine, cosine, or tangent? Tangent still, because we have O and A. Okay, so we're going to have tangent of 23 equals O, which is x, over A, which is 1200. When you cross multiply, are you going to be dividing or multiplying in the end? Multiplying. Because the x is separate from itself, so the rest of it can just go in the calculator. We would have 1200 tan of 23.
I'll do it. Hold on. Wait, no. Right now I'll do it.
Okay, so number 6. A ladder 6 meters long stands on level ground and rests against a wall at a point 4 meters from the ground. Here's my triangle. Here's the ladder. So because the ladder's leaning against the wall, the ladder's there. Okay? The ladder's 6 meters long, so where's the 6 going to go? Where the ladder is. It rests against a wall at a point 4 meters from the ground. When you see from the ground or on the ground, we're talking about like this. So shadows and 4 meters from the ground and something about the ground is always the bottom.
It says rest against the wall at a point 4 meters from the ground, so it's the height.
That's correct. Yes. But when we're thinking about ground, okay, most of the time when it talks about the ground, it's talking about the ground this way or the shadow this way. Okay? We do have to read it better because I didn't read it well whenever I was telling you that. But a lot of times the ground is on the bottom. It actually says at a point 4 meters from the ground. So yes, it's talking about the up and down part. Okay. What angle is the ladder? What is the angle the ladder makes with the wall? So what angle is it talking about here? So here's a time where we're not talking about that same angle, okay? It doesn't say anything about depression, so it's actually talking about that top angle that's inside the triangle, okay? All right, so if we label those two sides, Taylor, what would we do here? Sine, cosine, or tangent?
Sine.
Good. It would be sine, so we're going to say sine of the angle, or x. And then it would not be sine, actually, because that 4 is adjacent, because there's nothing across from that angle, so it's actually cosine. And then 4 over 6. This is the time where you have to do the second cosine. And you should get 48.18 or 9 or 2, however you want to write it. All right, number 7. Another ladder problem. A ladder is 20 feet, so the 20 is there. It's leaning against the wall. The base of the ladder is 3 feet from the wall. The base of the ladder is 3 feet from the wall. So is that up and down or across? It's across, because down here is the base of the ladder. And the wall's over here, so that's how far it is, so that's got to be 3. What angle does the ladder make with the ground? So that means that we're looking for this angle right here. Okay, set it up and let's see if you can solve it.
We're going to do cosine x over equals 3 or
And then what do I put in the calculator?
second cosine of 3 divided by
Good.
5. Oh, heck yeah, I just guessed.
And you get 81.3 or 4 when you put that in the calculator.